Hello everyone, it's good to be back in the States. My journey with Electrotherm and with Rob started 10 years ago when I came across to buy a wood chipper up in Portland, and one way or another I walked into a sawmill that had the only ORC that was installed in a biomass situation in the whole of the world at the time, and I walked through the door. And I was really impressed about it, and it was fate that got me there. And then when I got fly back to the UK, I missed my flight. So just a little story I've got to do. So I thought to myself, so I went to the desk and said, oh, no worries, Mick, we'll bump you on the next plane, being, I think it was American Airlines. So I said, can I be cheeky? Can you bump me on the day after tomorrow? Yeah, no worries, cost you $60. I thought, fair enough, no problem. So I said, can you book me on a flight down to Reno? So actually that day, flew down to Reno, met the team, and that's where the story began. And I'll just move on to the next one. So that is the graph of how our machines are installed. At that exact time, we had a big government funding for renewable heat incentive, which is to fund you to put biomass systems in. And even then, I identified if you put in a biomass system in, you should be generating electricity from it as well, if possible. And it really took off. And like Rob said, you know, we had a really good few years, and I think I was responsible for close on 30 of the 40, 25 of the 40 units in the UK now. And Joe, who is the current service engineer, and myself, between the two of us, we serviced those machines have been serviced by us from the get-go. I've now backed away because I'm getting a bit old. So Joe is 100% now looking after all our plant in UK. However, I have a very, very deep knowledge of integrating ORCs and biomass systems and all the problems and situations and heat load balances and the design. And it has just been an immensely educational journey. And then when we got, that will then bring us to where we are now, which is we have the C1000 developed. And that was born when the RHI finished. We as an engineer company said, what are we going to do now? So we decided we set out to do a small scale waste incineration system. That's how the C1000 was born. And then 5 years ago, first time I read about biochar and the terra preta and everything. And I knew that we could produce this black stuff because I had a fan failure and all this black stuff come out, which was unburnt ash. So I thought, well, if I try to make biochar and see how good this bit of kit we've got is for making biochar, which we did, and it was perfect. So cut to the chase, we developed the C1000, but it was developed from our knowledge of biomass boilers to be, the biggest criteria is to be simple, minimum moving parts, super heat efficient, and avoid a lot of the pitfalls in the standard kit. So now that we've done that, we feel we are at the, I would say the cutting edge. I don't want to, you know, we feel we're our C1000 is very at the top end of thermal efficiency. And I would always say if you want to know in a simple way as to how much thermal efficiency we got, how many kilowatt can we put on the meter coming out of the high temperature water to an ORC or any other use per ton of biochar produced? You know, that's the important part. You don't have to go into the big thermal dynamics, because if you've got, I mean, we when we're producing 500 kilograms of biochar an hour, we're putting 1 to 1.1 megawatt on the heat meter. Now that is more than enough to run the small unit of Electrotherm. And we feel on very good material, we could get up to closer to 1.2 meg, which is getting to the point when you can run the larger side. So then you're over 100 kilowatts of generation. Anyway, I'll move on to the next page. So our unit, which you can see in the bottom there, is totally self-designed by ourselves, in-house, in our small factory in the UK. We are a family-based company. There's myself, my daughter, who is runs all the show, and then Stuart, my son, is the main design engineer, and Darren is the main sales, marketing, and support. So what you see there is made in everything on that picture is made in our factory. And it's a flame curtain type of technology we use, which gives us a really good thermal transfer, because in the bottom of that unit we have a flame curtain, and then immediately above that we go instantly into biochar combustion chamber. So there's no transition between the pyrolysis process and the where you combust your syngas. And because of that, we don't get any thermal losses, hence why we get a really good efficiency. The other thing we've been really concentrating on is, as one of the speakers said before, if you have a drier material going in, feedstock going in, your thermal efficiency becomes higher. So we typically look to operate below 10%, possibly even 5%. Our main customer has been operating 12 months now. He's just had his EBC results back, and he was really good results. And this is proving that you can get really top-level biochar quite easily, because we've met agro-organic feed grade, which is the top level that you can achieve, and doing it with ease. And that machine you're looking at is currently generating electricity as we speak on an electrotherm. It's an older unit, because it was one of our older units off another customer. We took it back in and put it onto our system. Now this is a picture of our site. It's based on a farm. You can see where the C1000 biochar plant is, and as well as producing electricity, if you look to the left, that's going to be our new industrial building where we'll be fabricating the C1000s. You can see the red and the blue go into it. That's actually going to be heated with the condensing loop of the ORC. If you look at the industrial directly under the orange banner, that's wood drying kilns. Again, we use low temperature for the wood drying because we have it and we find it works well. So those two elements is what we use the heat from the rejection side of the condensing of the ORC. The other lines you see, which goes to our house and to our current factory, another house and another small industrial unit, that's all high temperature. And this is where it gets a bit nuanced, because you have to be able to design, install and operate, and the ORC and the heat source needs to talk to each other, and needs to be integrated controls to be able to automatically decide where your heat's going to go. You know, it's no good letting all the heat go to one unit and then you haven't got enough to produce the electric you want, or another time of day you might want to change things around. But we are constant. What it has meant to us as a production facility now, I would say we are probably one of the very, very few, or probably even the only, that are manufacturing a biochar plant using carbon negative electric, because we're producing electric as a byproduct of producing biochar. And that's a nice little number to have. But what it said more to me was, when we put the ORC in, our electric bill went from £10,000 a month to £2,000 a month. And 90% of that is a standing charge. You know, that's the real on element you will see when you have an ORC on the plant. And I always say that when you come to looking at the value of the electric, trying to export it to grid, it's hardly worth it. We do export to grid, but I don't even bother claiming for it, because the amount of bookwork and hassle it creates. I have to export to grid because if I produce too much power, it has to go somewhere, so I just give it back to the grid. But it's how much electricity you offset on your site. So if you can site one of these plants where adjacent to the site they have a good electricity use, that gives you a really good baseline to get really good income on it. But one of the big things is like Brody Biomass, who is our main customer, because obviously in the UK, I think we've got electrical costs of about 30 cents a unit, so it's very high, almost double what it is in the States. And his big complaint is his electric bill. However, he didn't have the financial capability, he couldn't raise enough funds to actually install an ORC when we put this plant in 12 months ago. But we set his complete system up all ready to plug in an ORC when he's ready to go. So I'm anticipating sometime in the next 6 months. Now he's just sold his first 1,000 corks. He's now got income, which is great. I think he got a really, really good price, close on 200 euros a ton for them. And a lot of that was done on the story. As one of the previous speakers mentioned, it's all about the story. You can get 100, 150, 180, 200. You have to make the story and sell your story on the market. And once you've got CHP and you're generating power, it's like when this is what we present. What you see here is what we present to our carbon platform across Puro. What you're actually seeing up there is how we explain why we are worth more than someone else. Yeah? So we're all in competition to be the best of what we can do. So I think that is pretty near. What's the next one? I think what I'll do now, I'll hand over to Rob because I am getting a bit croaky. I was not very well last night, so I'll hand over to Rob.
Thanks, Mick. So thanks, Mick. Batten cleanup here. Let's get to the chase. Let's go to the end first. What do I want you to take away from this presentation is there is a robust and reliable solution of a pyrolysis system and a power generation system that works. And during my tenure working at Electrotherm, we went through the early phase and it was hard. There was a lot of pain and suffering. And now to have Electrotherm where it is now with the reliability, and as you guys that have installed it, they've done a great job. But we've still got to integrate it with the pyrolysis system. And that's what the rest of this presentation gives you. Because I'm a hard case on I want to make sure that the business case works. Because I've seen people try and install things because they thought it was a good idea. And when they finally got to the end of it, it really wasn't. I'm really hard pressed to challenge everyone to run their numbers and make sure that their math is right. So what we wanted to do, which is a little bit unusual, I realize, for a presentation, but we really care about people being able to do the math. So we've put this together on throughput. You can use it as a template. Your numbers will vary, but these are budgetary for us, and they're not far off. So with that in mind, you can look at an annual income of approximately $650,000. So that's a good target for you. What's in that? This. About a $2.5 million full plan turnkey, which includes these following things. And this is how you do your business case, at least at a high level in the beginning, to see if you can get to a go or no-go to the next step, right? You go through the list. It's the fuel store, the dryer, day hopper, biochar plant, heat exchanger, including the flue gas scrubbing requirement, the ORC, mechanical installation. We've got it all budgeted in, process piping installation. So why is Torc Power here with Woodtek? I'm here to support Woodtek in the US on the sales and integration of their technology wherever it needs to be installed. Torc Power will do as little or as much as you would like us to do. We can provide a turnkey installation. If you look at the very bottom line, what's not included is we don't put a building up, we don't do the civil. There has to be water and electric and a biochar bunker. But everything else to be able to install and run a pyrolysis system with an ORC is listed here. So I hope that's helpful for you as it's in the end, it's always about the numbers in some capacity. Combine heat and power to biochar, how to scale it. Clearly, technology like the C1000 and others are becoming more accessible worldwide. We know that we're ready to install the first unit in the US Q1 of 2026. And again, getting back to the math, each plant can deliver nearly 10 megawatt of thermal. Anyone that wants this presentation, you can have it. If you look at the brochure that is on the table in front of you or up here on the front, my email and contact information is there. Let me know, I'll send it to you. Because taking pictures, I do it all the time at presentations, but just so you know, it's available. Our goal is to combine large-scale carbon removal with usable clean energy. We know we can do it, we know the path to do it, and it's repeatable. Currently, Woodtek is manufacturing everything that they do in the US. As far as the ORC, it's manufactured here. Our plan is to spool up and manufacture in US as demand increases, which we see on the horizon. That gets us made in the USA, as we all like to be, and it gives us a dedicated US facility. Our goal is also to, just like Mick has at his place, which I hope some of you have been to Mick's place, I see you over there. If you ever get the chance to go to Mick's place and see his system running, I encourage it. When we do get set up in the US for manufacturing, it'll include C1000 so we can do it here. I hope that gave you a good overview of kind of where we are headed with integrating CHP with pyrolysis. We've got people at the table that know how to do it, and we're available to support you. Thank you very much.
Great. Thank you very much.